Hello everybody, my name is Derek Del Cruz, and today I'll be presenting my work for the Chapter 23 project of the AP Physics curriculum. Let's get started. Before we get started, there are a few important terms that we should define. The first one is series, which means that components are connected from end to end, and in the picture example we see 4 resistors connected in series. The second term we should define is parallel. In the context of circuits, this means that the components have diverging paths, but they're still connected to one current. And in the picture there we see an example of 4 resistors that are in parallel connection. And the final term we're going to define is an RC circuit, which essentially just stands for a resistor-capacitor circuit, which is just a circuit with resistors and capacitors. There are also some important equations we should define. The first one is finding the resistance of resistors that are in series connection. In this case, you just add the resistance. Quick reminder that resistance's units is ohms. The next equation is to find the resistance of resistors in parallel connection, and in this case you would add the inverse of the resistance. Another equation we should define is finding the charge of the capacitors, which is equal to the voltage multiplied by the capacitance. The next equation is finding the capacitance of capacitors in series. In this case you are adding the inverses of the capacitance in the capacitors. And the final equation is finding the capacitance in parallel capacitors, and in this case it would be just adding the capacitance together to get the final one. This is the circuit I have created. It has a 9-volt battery that travels to a switch, and the switch is able to turn the circuit on and off. There are 2 resistors, both of them in series, and then after that 2 resistors which are in parallel. From there are 2 LEDs that are in series, and then 2 LEDs which are in parallel. Followed by that is a DC motor, and then 2 capacitors which are in series, and lastly 2 capacitors that are in parallel, which finally connects back to the negative terminal of the battery. These are the different values of information for each component. The battery has 9 volts, and then the 2 resistors in series have 5 ohms and 3 ohms. The 2 resistors which are in parallel have 2 ohms and 6 ohms. The 2 light bulbs in series have 3 ohms and 3 ohms. The 2 light bulbs in parallel have 3 ohms and 4 ohms. The DC motor has 10 ohms. For the 2 capacitors in series, they have a capacitance of 10 microfarads and 5 microfarads. For the 2 capacitors in parallel, they have a capacitance of 4 microfarads and 10 microfarads. Applying the equations we learned earlier, we can simplify some of these numbers. For the 2 resistors in series, 5 plus 3 is 8 ohms. For the 2 resistors in parallel, we have to add the inverses, which gives us a final resistance of 1.5 ohms. For the 2 light bulbs in series, which just act as resistors, we can add 3 ohms and 3 ohms together, which gives us 6 ohms. For the 2 light bulbs in parallel, we have to add the inverses of 3 ohms and 4 ohms, which gives us 1.7 ohms. The DC motor has a resistance of 10 ohms, and that's just by itself. The capacitors act a little bit differently. For the 2 capacitors in series, we have to add the inverses. So we would add the inverse of 10 microfarads and 5 microfarads to get a final capacitance of 3.3 microfarads. For the 2 capacitors in parallel, we can just add them together, giving us a final capacitance of 14 microfarads. According to Kirchhoff's loop law, we know that voltage will eventually decay across the resistors. So using the sum of the voltage, knowing that it will equal 0, we can solve for current. And the final current that we get is 0.33 amperes. And now that we have current, we can solve for the amount of voltage lost at each resistor. So that's just multiplying the current by the resistance. For the 2 resistors in series, the first one loses 1.65 volts and the second one loses 1 volt. For the 2 resistors in parallel, they both lose 0.495 volts. For the 2 light bulbs in series, they lose 2 volts. And for the 2 light bulbs in parallel, they lose 0.561 volts. And for the motor, which has a resistance of 10 ohms, it loses 3.3 volts. Adding these all together gives us 9 volts. Calculating the amount of voltage lost of the resistors, this was assuming that no amount of current has reached the capacitors yet. Now in this case, we're going to be figuring out how much charge has reached the capacitors and how much they actually hold. Now we can use the equation that we learned, which is charge equals capacitance times voltage. Plugging in the values, we have 2.7 microfarads times 9 volts, which gives us a final charge of 24.3 microcoulombs. Thanks for watching.